class label attribute is discrete valued and unordered. It is categorical in that each value serves as a category or class. The individual tuples making up the training set are referred to as training tuples and are selected from the database under analysis. These training tuples are also referred to as samples, examples, instances, data points or objects. And we will see the difference between supervised learning and unsupervised learning. Supervised learning is associated with classification, and unsupervised learning methodology is used in clustering. Because the class label of each training tuple is provided, the classification step is also known as supervised learning. That is, the learning of the classifier is supervised in that it is told to which class each training tuple belongs. That's why it's known as supervised learning. In contrast with unsupervised learning, that is used with clustering, the class label of each training tuple is not known, and the number or set of classes to be learned may not be known in advance. Now we will introduce the concept of classification accuracy. We will study detail in the last sessions of this particular module. This step is associated with the second step, that is classification step. First, the predictive accuracy of the classifier is estimated. To measure the accuracy of the classifier, a test set is used, made up of test tuples and their associated class labels. These are randomly selected from the general data set. These are independent of the training tuples, meaning that they are not used to construct the classifier. The accuracy of a classifier on a given test set is the percentage of the test set tuples that are correctly classified by the classifier. So the accuracy is calculated as the percentage of test tuples that are correctly classified by this particular classifier model. The associated class label of each test set or test tuple is compared with the learned classifier's class prediction for that tuple. Now we are once again seeing the difference between the prediction with the classification. Data prediction is also a two-step process similar to that of data classification. However, for prediction, we lose the terminology of class label attribute because the attribute for which values are being predicted is continuous valued or ordered rather than categorical. That is, we are using continuous valued or numeric values as the predictor attribute, and these are referred to as predicted attribute. Example, we wanted to predict the amount that would be safe for the bank to loan an applicant. We have seen this example. The data mining task becomes prediction rather than classification while we are using this predicted attribute and we want to predict the particular case. We would replace the categorical attribute loan decision with the continuous valued loan amount as the predicted attribute and build a predictor for our task. So this can be explained when a question arises, what is the difference between prediction and classification, and you can add some more points regarding this when we come to the issues regarding the these two methodologies, that is prediction and classification. Now we are discussing about issues regarding classification and prediction. First issue is we have to prepare the data for classification prediction. We have to follow some steps, that is data cleaning. We have to analyze the relevance, then data transformation and reduction. You can add points that we have already discussed with these pre-processing steps. And the second issue is regarding the comparison regarding the classification prediction methods. Classification and prediction methods can be compared and evaluated according to some criteria. First one is accuracy. The accuracy of a classifier refers to the ability of a given classifier to correctly predict the class label of new or previously unseen data, that is tuples without class label information. We have to decide which classifier which class that particular tuple belongs to. Similarly, the accuracy of a predictor refers to how well a given predictor can guess the value of the predicted attribute for new or previously unseen data. Examples include estimation techniques such as cross-validation and bootstrapping. Criteria is regarding speed. This refers to the computational cost involved in generating and using the given classifier or predictor. Next one is robustness. This is the ability of the classifier or predictor to make correct predictions given noisy data or data with missing values. We may have different types of data which contain noisy data as well as some missing values, whether it will predict correctly. That is the robustness. Scalability. This refers to the ability to construct the classifier predictor efficiently given large amounts of data. Some data models will be good for the minimum data set, but we have to check whether it will give accuracy with a huge amount of data. That is scalability. Interpretability. The next one is interpretability. This refers to the level of understanding and insight that is provided by the classifier or predictor. So these are the criteria that can be used for comparing a predictor and classification models. So these are the issues regarding classification and prediction.